Hi, my name is Jake Lehle, and I'm a PhD student at UTSA. The title of my talk today is Susceptibility to Endocrine Disrupting Chemicals, or EDCs, and Transgenerational Inheritance of Disease Pathology. Now, EDCs are chemically that sterically or structurally look like hormones. A lot of people have often heard about an EDC called BPA, and they were trying to get it pulled out of plastics. But what people don't often know is that that EDC, it actually looks like estrogen. So researchers like me were concerned about trying to get that out of plastics. So we didn't want people constantly being signaled by tiny little bits of estrogen all the time. So a lot of studies in the past have shown that EDCs are dangerous because pregnant women, when they're exposed to EDCs, have a high likelihood of actually having offspring that can develop disease states, and then that disease state can be passed over multiple generations. So on my slide, I've drawn some pictures to try to illustrate that point. So you can see here we have a pregnant mother that's been exposed to EDCs. Now, if you look at number one, you can see that that mother, or the F1 initial generation, is getting exposed. The fetus, or the baby, F2, the second generation, is also getting exposed. And then on top of that, the third generation, or the F3, is all getting exposed by that initial one-time EDC exposure. If you look at number two, we can see the transgenerational inheritance of that damage from that EDC exposure. So the mother has gone and had a daughter, and that daughter has in turn had a granddaughter, all of which are living with the damage from that initial EDC exposure. And if you look at number three, unfortunately, we can see in the granddaughter, she has developed a disease state because of that initial EDC exposure. Now you can see this is a very big problem. These chemicals are around us all the time, and if they're leading potentially to not only disease states in ourselves, but also future generations, we really want to try to understand what's going on. Now, in the past, a lot of these studies have been done in animal models, but there have been a lot of issues with using animal models. They're very expensive to do these kind of studies. It takes a lot of time, and the animals are so complex, we really don't understand yet what cell types are susceptible, if there's differences between different cell types, what's the mechanism, and how does that damage actually lead to disease states. So I propose in my study to use stem cells rather than animal models to be able to address these problems. If we take stem cells, we can turn them into many different cell types and address some central problems, which I'm going to talk about now. We can start with what cell types are susceptible to EDCs. If I've got a bunch of different cell types and I hit them with an EDC, I can say, well, this cell type's susceptible and that one's not. Secondly, and number two, do those cell types that are susceptible have differences in expression of something we think might make them susceptible, like a hormone receptor? If these chemicals look like hormones, we think maybe if that cell type has a hormone receptor, that would make it susceptible. And finally, three, how is it that this damage that's being caused leads to a disease state? Once we know what cell types are susceptible, we can ask much better questions about what is the damage that's happening in that cell type and how does that lead to a disease state later on. If we can understand that, we have a much better way of protecting not only ourselves, but future generations. Thank you so much for your time.